In this video, we're going to be looking at the interpretation of a cubic function. Okay, so they say consider the graph of the derivative of g of x. Let's start there, ladies and gentlemen. They say we are given what? The derivative of g. What does derivative mean? Remember, this means gradient. Ne? Gradient. So we are basically given the gradient of the function g of x. And you can see that this is parabolic, which means the function g of x is what? Is a cubic function, right? This is a cubic function, right? Perfect. So before we answer the questions, I need us to analyze this thing, the diagram that we are given, right? So I'm going to divide it into some few parts here, and then there. Then let me pick a different color. And then we have this part here, and then there. Right. Awesome. And then we now have this. Let's see. We can see that, okay, these are the points on the derivative. The first one, it's 1 coordinate 0. The second one is -2 coordinate 0, right? And don't forget that here is the y-intercept. So on the, is the x-intercept, and on the x-intercept, the y value is equals to 0. That's how I got that 0 and that 0. But the y value is basically this, right? So it's where the derivative is equals to 0. Which means here we have a turning point. So this is the x value on the turning point, and also that is the x value on the turning point. How did I know that? It's because the derivative, remember this is the function of the derivative. So the y values represent the derivative basically. So the derivative is 0 here, which means these are the turning points. Okay, perfect. And then let's check another thing, ladies and gents. We know that, okay, here, the derivative, this, it's positive, right? Which means the gradient is positive, and also this side. Remember, the derivative refers to the y values. The y values here are positive. All right? And then let's now check this. Here, we are negative. We are negative. So here, we are negative. So the derivative is negative here, which means the gradient is negative on the blue, and it's positive on the yellow. So where I highlighted yellow, the graph is increasing. The cubic function is going to be increasing here. Why? Because the gradient is positive. If the gradient is positive, it means that the function is increasing. Right. Perfect. And then here between -2 and 1, the gradient is negative. So which means the graph is decreasing. Right. Now we can go and answer the questions. But before I go, let's just make sure that this one is also accounted for. We know that this is the y-intercept. Therefore, we make x 0. Then we have that. All right. Now we can answer the question. The first question says what? Number 1. They say we need to, for which values of x is g decreasing? So we said we are decreasing on this part here, right? So we can see that, okay, we are decreasing from -2 to there and then there, right? So we are decreasing between -2 and 1, right? And you do not include -2 and 1. Why? Because those are your turning points. On the turning points, we are stationary. We are neither increasing nor decreasing. What I mean is you cannot write it this way. So always when a question asks about increase and decrease, do not include the solutions. Ne? Some people can write it this way. X elements from -2 excluding -2 to 1 excluding 1. Those are the two ways you could write. I'll just say or there. Those are the two ways you could have written the answer for that. They say determine the x coordinates of the turning points of G. So they need the x values on the turning points. Remember, I said this is the XTP1, then also that is the XTP2, right? These ones. Those are the x values on the turning points, or x equals to 1. How did I know that? Because the derivative is equals to 0. Right. Perfect. Now we can go to number 3. Remember turning point, the derivative, this, let me just write here to remind you. For the turning point, the derivative must be 0. So I looked for where the derivative is 0. The derivative is 0 on the x-axis. So our x-intercept of the gradient function is the turning point x values on the original function. Right. And then let's go to number 3. We are given that g of x is equals to a x cubed plus b x squared plus cx. Right, I'm just going to get the derivative because here we are given the derivative function. You can see that this is 3ax squared plus 2bx plus c. Right? And then now we are sorted, ladies and gentlemen. We have 3 points and we have 3 unknowns. So it's easy to deal with them. I'm going to substitute all the points in here. The unknown, remember, it's A, B, and C. That is what they're wanting us to look for here, A, B, and C. And it's easy. We have, remember, this is that, you see? So we're going to work mostly with this guy because that is the graph with which we have its function. Awesome. So I'm going to substitute the y-intercept first. It's always easier to substitute the y-intercept. So the y value is -6 is equals to 3a0 squared plus 2b0 plus c. Okay, -6 equals to, you can see that this guy will be 0 because of that. Everything gets 0 there. Everything will be 0 here because of that guy. So you are left with C. Then you can see that, okay, C is -6. Now we're done substituting this one. I'm going to now substitute that one. So I'll just, let me just show actually to say subs 1 coordinate 0 into G prime X. So there, what do we get? We are going to get the Y value is 0. And then we have 3a1 squared plus 2b1 plus c. Ladies and gents, don't make a mistake and substitute into this one. Remember, this one you don't know. It's not given. You are given the graph of the derivative. So you use the derivative. 0 equals to 3a plus 2b plus c. Because there's 3 times 1, which is 3, then there's a. Here's 2 times 1, which is 2, then there's b, then there's plus c. But we know that c is -6, so we're going to substitute it. Rather, let's substitute it. So c is -6. So here I'm going to say -6 and -6. Sharp. And then now let's see what happens. You can see that, okay? Here we have a 0. Okay, let's do this. I'm going to move the 3a this side. So it's going to be -3a and the 6, plus 6 equals to 2b. Someone could have moved the 2b and left the 3a. It's entirely your own choice. Sharp. So I'm going to divide everything by 2 so that the b can be left alone. So we have this, ladies and gentlemen. We're going to have that guy, it's -3a over 2 plus 3 equals to b. Right. Awesome. Now we're going to repeat the same thing here, but now we're going to substitute this point. We're going to substitute -2 and 0 now, né? -2 and 0. So I'm going to say here, I'm going to say sub -2 coordinate 0 into the graph of the function which is given, which is the derivative function. So I'm going to rewrite this whole thing, which is 0 equals to 3a. Then I'm going to open a bracket there, plus 2b, open a bracket, minus 6. You can see that here there was 1, but now we substitute in -2. The 0 is already substituted there. We need to put -2. If you check this step and that step is exactly the same. Here we're substituting 1. That's why there you have 1. Here you're substituting -2. That's why you have -2 there. And then now we can move on. 0 equals to 12a plus -4b. Or some people will just say -4b, which is still fine. And then -6. I'm sure we can all see that, ladies and gents. Now we can substitute. We can subs b here, right? So where we see b, we can put this. We can replace b with that because we're saying here b equals to this guy. So I have 0 equals to 12a plus -4. My b is what? -3a over 2 plus 3. That is my b. And then we have -6 here. So -6. Then now the good thing is we no longer have b. We can easily solve for a. So you have 0 equals to 12a. Let's write it here. 0 equals to 12a. This times that, it's positive 12a divided by 2, which is positive 6a. And then -12 minus 6. Right? And then now we can see that, okay, here we're getting 18a, here we're getting -18. So I'm going to move that side to become positive 18 equals to 18a. Therefore, we can all see, ladies and gents, that if we divide by 18 on both sides, our a is 1, right? And then therefore, we can easily get what b is. B is -3. Our a is 1, 2 plus 3. I'm substituting on this step, ladies and gents, né? On this step here. So that guy is there. And then where there was a, I put 1 because a is 1, then plus 3. Now let's see what does that give us. So that gives us -3. This will be plus 6 over 2, which gives us 3 over 2. So you found everything. Your b is there, your a is here, and your c, we got it as -6, right? Somewhere up there. There. And that's finito with this question, ladies and gentlemen. If you found it helpful, don't forget to advise your friends to join us in the family of Maths Fanatics 24/7. Aluta continua. Tango.